All right, these postulates we'll spend some time on tomorrow, but let's see if we can do it right now. How many points do I need in order to know where a line is? So if I have 1 point, and I tell you to visualize a line that goes through that point, are we all visualizing the same line? Probably not. We have horizontal, we have vertical, we have oblique, we have all these different lines that could go through that point. What if I provided you with 2 points? And I wanted everybody to visualize the line that goes through those 2 points. How many different lines can you see that contain both those points? I think most of us will agree that there is one. So 2 points determine a unique line. If I give you 2 points, we all know the one and only line that goes through those 2 points. Okay. If 2 distinct lines intersect, then their intersection is a point. I think most of you are familiar with that from solving systems in algebra class, that if we have 2 lines, they can be parallel, they can actually be the same line, or they can intersect in a point. All right. Now, what about a plane? If I have 2 points, I see my piece of paper here as a plane. I also see a plane that could go cut through this way and cut through this way. So I see an infinite number of planes. But if I have 3 points, then the only plane that contains all 3 of those points is this flat piece of paper. So 3 non-collinear, very important, points determine a unique plane. And if 2 planes intersect, so if I have a plane like this, and then I have another plane jutting up, whoops, that curved a little bit. Oh well, that's all right. These are the points that they have in common. So if 2, let's draw one more picture here. My box again. The front and the top of this box, the front and the top, they intersect in this line right here. These 2 planes intersect here. Imagine the binding of a book with all those planes being pages. If 2 planes intersect, then their intersection is a line. Okay. Now that we have the terms, let's just take a look at a few pictures here. All right. So this point P is on line R. I know that's a line because it's lowercase script. I know this is a point. Well, the sentence starts with the word point, but even if it didn't, I know that this would be a point because it's an uppercase, not non-script letter. Okay? So that's one way of saying this. We also could say line R contains, or line R passes through. Okay, so all of these are appropriate ways to describe what's happening in that picture. Okay, the second picture, we have lines S and T. And what happens at Q? Sorry, W. Lines S and T intersect. Point W is the intersection of S and T. And point W is on S and T. So points are on lines, lines go through points. Okay. line L and point R are on plane N. And you can see how there's a little script thing going on here, so I know that that's a plane, okay? Point R lies on N. Point R lies on plane N. Plane N contains. Plane N contains both R and L. Line M intersects plane N at point R. And you can see how important the notation is here. I just have a big uppercase N here, but I know it's plane N, and I know that this means point R. This one is script, this one is not. Okay? Point R is the intersection I didn't leave enough room of M with N. Okay? Now this is a very, very important one. Do lines L and M intersect? Here's L, here's M. Now remember what this is showing. This picture is showing a three-dimensional situation on a flat two-dimensional surface. So here we have a line punching through right here a plane and then disappearing behind it and coming out the other end. And here we have a line somewhere on a plane. This line M is in the forefront. It's way in front of line L. Do lines L and M intersect? No, they do not. Does plane N contain this line M? No, it does not. It only contains point R. For the plane to contain the line, it must contain every point on the line, not just one. Lines L and M are called skew. Okay, they're in different planes and they do not intersect. They're called skew. Okay. Now here we have, you can see what happened here. We have a line, intersecting lines, a plane with lines in it and a line intersecting the plane, and finally two intersecting planes. So this final picture contains an illustration of points, lines, planes, intersecting planes. Okay. So we have line AB, and it is in plane P, and it is also in plane Q. So line AB, this is red, line AB is in planes P and planes Q. Point A lies in both planes P and planes Q. Planes P and Q contain. And now there's other ways that you might say these things that are absolutely right, but I want you to get comfortable with words like in, on, contain, through, intersect, lies on, that kind of thing. So planes P and Q both contain AB, and planes P and Q intersect. In AB. Finally, line AB is the intersection of Now, tomorrow in class we're going to have to do some drawing, so make sure that you have a sense of how you draw these various things. You can see we use dashed lines when things disappear. When things intersect, we draw their intersections. Okay, I think we are done for today. Good work.